Well, what is sharding? It's a big buzzword, especially in EVM land. How does it apply to anything?
When we talk about scaling and just scaling like basic systems, like a database, this concept of sharding comes up. Basically what it is databases effectively have a certain read-write speed that you can put through them. So if the system scales beyond that read-write speed, you create sort of instances, like multiple instances of the database. But the problem is you need to then also sort of shard what data goes into those instances. In the case of Facebook, you might say everybody's data who has names A through M are in sort of the first shard and N through Z are in the second. And then when they go to sort of access the system, they know, oh, I should go to shard 1 or I should go to shard 2. And then as the system grows, you can keep further sharding those systems with scale. So this is sort of a common technique that's used with databases where when one database is not enough, you kind of separate your data into many databases. Now with blockchains, you have an extra piece on top of this, which makes this especially difficult, which is you have to maintain consensus amongst those shards. And so consensus isn't something you can truly shard because you ultimately have to have one canonical understanding of the system, ledger, and agreement. So although you can separate the data, you then have to have a robust consensus mechanism that sort of allows you to say what you think the canonical state is of the aggregate system at any point in time.
You need a single source of truth, like ledger, that has all of the everything on it that people can refer to as a true referent of the data. And then the shards, how do they assist a network if you still need a single source of truth? What benefit are they adding by existing?
Well, it allows you faster read-write access. If you can increase throughput, i.e. in blockchains, transactions per second is a decent proxy by having shards.